Hey guys, in this video I'm going to talk a little bit about the difference between linear equations, exponential equations, and then how to tell the difference with their tables. So the first example we have is y equals 3x. And the question is, what does the graph of this equation look like? Well, an equation that forms a line is a linear equation. We've dealt with that a lot during first semester. So first let's take a look at the relationship in the table here using this equation. So I'm going to substitute in each of these values for x to see what I get for y. 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. Now take a look at those y values. There's a pattern there to be noticed. And the pattern is that for each y value you go up, you're adding 3 to it, which makes sense because my rate of change, or my slope, is 3. That means for every x value, I should add 3 to the y value. So in general, a linear equation is described by a constant increase or decrease using addition or subtraction. Depending on whether or not it's increasing or decreasing. So if you're looking at a table of values and it is either adding the same amount for the y's every time or subtracting the same amount for the y's every time, that means that you have a linear function. Now let's take a look at y equals 3 to the x. So that means that I have a variable as my exponent, okay? So an equation with a variable in the exponent is called an exponential equation. We're going to do the same thing we did for the last one. We're going to plug in values for x and see what we get for y. 3 to the 0 power is just 1. 3 to the first is 3. 3 squared is 9. 3 to the third is 27, and that extends, or that is the extent of my knowledge here. So 3 to the fourth is 81, and 3 to the fifth is 243. Once again, there is a pattern to be had here on the y side of the table. You should notice that from 1 to 3, you can multiply by 3. And then from 3 to 9, you can also multiply by 3. So every single time for an exponential equation, we are multiplying by the same amount. And it just happens to be the number that is being raised to the exponent of x. So in general, an exponential function is described by a constant increase or decrease using multiplication. So again, if you're given a table and you have to decide if it's linear or exponential, all you need to do is take a look at how the y values change. If it changes by addition or subtraction, you're dealing with something that is linear. If it's changing by multiplication, you're dealing with something that is exponential. Let's take a look at how that works. So example 3 says, fill in the table describing an exponential relationship. So the first thing it says is, what is the constant multiplier for this relationship? Now, the key here is that they told us that it's exponential. That means as I go down the chart, I am multiplying by the same amount every single time. So to go backwards, the opposite would be to divide by the same amount every single time. So to figure out what that amount is, I'm going to take one number and divide it by the number on top of it. So in this case, 1296 divided by 216 is 6. That means my constant multiplier is 6. And I can fill in the chart the rest of the way using this 6. So 1 times 6 is 6, 6 times 6 is 36, and 36 times 6 should be 216. And then if I multiply by 6 again, I get the 1296, then 7776, then that big number down there at the bottom. Okay, so if I wanted to write an equation that represents this relationship, I would use a form like this. It's y equals a times b to the x, where a is your starting value and b is your constant multiplier. Your starting value is still whatever y is when x is 0. So in this case, it's 1. So I don't need to write it. But I am going to fill in b, which is my constant multiplier of 6. So I would just get y equals 6 to the x. And that's it. That's how you would decide whether a table is linear or exponential and write an equation for it.